Okay, now let's look at another interesting lemma, which actually follows from the convergence. We can use the early convergence result here and try to bound the elements of a matrix. Okay, this is like a corollary of the previous result. Let A as an n-cross-n matrix, and we have an arbitrary small epsilon which is greater than 0. If this is given, then there exists a constant C such that for the k power of A, the k power of ij will be less than or equal to this constant C times rho of A plus epsilon raised to k. So what this means is, if you have a matrix, then for the k, we are finding the kth power of a matrix, right? So we can easily determine an upper bound for the maximum value, the modulus of the maximum value, which each element of each element of the a raised to k power of this matrix, like a raised to k, its ijth element the maximum value it can take is some arbitrary constant c times spectral radius of A plus epsilon raised to k. For all k is equal to 1, 2, etc. And for all ij equal to 1, 2, etc. So there's nothing like the idea of convergence here, in the sense that k is not tending to infinity. This is like, suppose we are at 10 power of k, right? We are finding a raised to 10. Okay, then we are trying to find ij of what is the maximum value ij can go. So we can upper bound it by this value. So let's try to prove this. The proof is actually, it involves some construction and also ideas from convergence of matrix. So for that, initially we constructed a matrix A tilde is equal to rho times A plus epsilon whole inverse A. And this has okay, this is the new matrix. And for this new matrix A tilde, the spectral radius of A tilde will be less than 1. How can you tell that? See, for A, we have AX is equal to lambda x, right? Or we can even write yeah, AX is equal to lambda x is the condition where we have an eigenvector. So, okay, let's say lambda A rho A corresponds to lambda. Then if we multiply this by rho A plus E, right? This is actually rho A. So rho A by rho A plus E, this is an arbitrary value which is greater than 0. This value will be less than 1. So this, in fact, for this new matrix A tilde of x is this into x. So this is the new eigenvector, which is like lambda dash x for A tilde, and this is the max. So this value will be always less than 1, right? Because it's rho A is a positive quantity, rho A plus epsilon is also an arbitrary small quantity which is greater than rho. And rho A plus A will be greater than rho A. So this value will be fraction will be less than 1. So this is again an eigenvector of the matrix A tilde, where A tilde is given by rho A1 or A by rho A plus epsilon. For that matrix, the spectral radius is less than 1. So if the spectral radius is less than 1, then we can say that A tilde is convergent, right? Implies A tilde is a convergent matrix. Which means that A tilde k raised to k tends to 0 as k tends to infinity. So what does this mean? A raised to k goes to 0, right? As k tends to infinity. So the values of A raised to k are actually coming down and down. It's becoming smaller and smaller. So the entries of sequence, entries of the sequence, suppose we are going from A squared, sorry, A tilde squared, A tilde cube, etc. A tilde 3, A tilde raised to k. Then all the entries will be bounded, which implies there exists some c which is greater than equal to 0, such that modulus of A tilde raised to k ij is less than or equal to c for all k and for all ij. Because it is going to be bounded as we go for the higher powers, right? What does this mean? This is A tilde aj is less than or equal to c, but A tilde of k is nothing, but we have a constant term, right? Which is rho of A plus epsilon whole inverse. If you write this in terms of A power k, this is A power ij, this is less than or equal to c, or the ijth term of A raised to k is less than or equal to some c times rho A plus epsilon. So this is some guarantee which we have. Sorry, did I miss something? No, this was for, yeah, sorry. It's to k. So here there's a k. From every element we are taking out. Okay. From every element are we taking out? Yeah. So this is not a determinant. This is the modulus of AKIG. So it's not determinant. So we don't get confused. This is modulus. Okay. So there are k terms. No. I think there are. Yeah. Why there's a confusion now? A is actually. Yeah. This is correct. There's no need for any confusion. Okay, this is how we can prove this lemma. So by this lemma, what we're trying to mean is we're trying to bound. There's a bounding upper bound guarantee for any matrix A power k in terms of its spectral norm. Okay, let's conclude this discussion.